Okay, worksheet 2. Looking at number 1 for the trig identities, um, I would look at this and say this side looks like maybe it looks more complicated because it's a fraction, but I really can't do anything because it's already in terms of sine and cosine, so I definitely would start with the left side. Write it in terms of cosine and sine, so that'd be 1 over cosine. This would be sine over cosine, so that part was easy. That's a trig step. Algebra step says we can just put those two fractions together since they have a common denominator. But that's where you probably got stuck, because if you look at this, it's similar to what you have over here, but not really, because I want a cosine on the top, not the bottom. So different ways I could do this, but what I would probably think of right away is let's multiply by the cosine over the cosine. Now in the numerator, I'm not going to distribute that cosine out. I'm not going to take cosine and cosine sine. I'm not going to do that because I want to keep the cosine on top. So I'm just going to write it as the cosine times 1 minus the sine. And in the denominator, I've got cosine squared. Okay? All right, now, right away you would think, oh, let's just cancel out one of those cosines. Well, if you do that, you're going to be right back to where you started from. So canceling out a cosine doesn't really help you right now. You want to keep that cosine. What you want to cancel out is this 1 minus sine. So then you look at the Pythagorean identity for the bottom and say cosine squared is really, let me rewrite the numerator, cosine squared is really 1 minus sine squared. So all I did is I rewrote that denominator to be 1 minus sine squared. That's the difference of squares. It factors into 1 minus sine times 1 plus sine. The denominator factors into 1 minus sine times 1 plus sine. And then I see that the 1 minus signs cancel out, so I'm left with what I wanted, cosine of theta over 1 plus sine theta. So again, just to recap what we did, we weren't sure what to do. We put everything in terms of sine and cosine. We already had common denominators, so we could put them together. That step we kind of got stuck, so we said let's kind of cheat and look to see where we're going. So I multiplied by cosine over cosine. Could I have multiplied by 1 plus sine over 1 plus sine? Sure. I just looked at the numerator. So I didn't distribute that out because I want to keep that. I knew I wanted to get rid of this. When you see a squared, always be thinking Pythagorean identities, which we did. That can be factored as the difference of squares, and then the 1 minus signs canceled out. Okay? All right, number 2. 2 looks very confusing because you've got 3 sine squareds and 4 cosine squareds. So one thing you could do is you could just write this is the same thing as sine of theta, sine squared of theta plus sine squared of theta plus sine squared of theta. This would be 4 cosine squareds added together. I looked at this and said, I know I want to end up with a cosine squared all by itself. So I rewrote this as 3 sine squared plus 3 cosine squared plus 1 cosine squared. I just broke up 4 of those into 3 of them and 2 of those. Now the reason I did that is these now can be kind of grouped together. I factored out a 3 because they both have a 3 in common. I left this plus cosine squared out here all by itself. And then I see sine squared plus cosine squared I know is 1. And now I see that I'm left with 3 plus that cosine squared. And that's what I was looking for. So because I wasn't sure what to do and I had all of this stuff going on, I just grouped 3 of them together, left this cosine squared out here by itself. So rewrote 4 cosine squareds as 3 of them plus 1 of them. With these two, I factored out the 3, and then sine squared plus cosine squared was 1. All right, let's see if we can do number 3. 3 again, I'm pretty sure everybody would think that you want to start with the left side. So again, we probably want to put it in terms of sine and cosine. So sine squared minus sine over cosine over cosine squared, minus cosine over sine. All right, so that would be the first step. Then I see this complex fraction, so I have to get rid of cosine and sine. So the least common denominator has to have a sine and a cosine in it. So when I multiply, I'm going to multiply by sine cosine over itself. So every term in the numerator and denominator, I have to multiply by sine cosine. So it's going to still look a little bit ugly. When I take this times sine squared, well, I'm going to have sine to the third times cosine. I don't like that sine to the third, but we'll have to deal with that later. Second one, the cosine will drop out, so I'm going to be left with sine times sine, which is sine squared. All right, in the denominator, sine times cosine cubed. And the cosines will drop out, or no, excuse me, the sines will drop out, and I'll be left with minus cosine squared. All right, now I'm still looking at where I'm trying to get to. I'm trying to get to tangent. So when I look at this thing that looks pretty ugly, I look to see that, okay, in the numerator I can take out a sine squared. That's common to both. So let's factor out a sine squared. I'd be left with a sine cosine there. And here I'd be left with minus 1. And in this one, I can take out a cosine squared. Whoops, I can't see that. Take out a cosine squared from those two, and I'd be left with sine cosine and a minus 1. And then I see that these drop out. Sine squared over cosine squared is tangent squared, and that's what I was getting to. Okay, so it looked kind of ugly. It really wasn't that long of a proof. We again took tangent to be sine over cosine and cotangent cosine over sine. We had to multiply by the least common denominator to get rid of those two fractions. And so we were left with something that looked a little ugly at first, but we just decided let's take out what's common. So those two had a sine squared in common, factor that out. The denominator had a cosine squared, factor that out. And once they went away, we were just left with sine squared over cosine squared. All right, let me see if I can maybe get number 4 in this video as well. Number 4, again, looking at which side to start with, I probably would start with this side because it has secants in it. So I would write secant as 1 over the cosine. All right, and then again, I have this complex fraction, so I'm going to multiply by the least common denominator, which is just cosine theta. And when I do that, I'm going to get 1 over cosine for the first term, and then when I multiply these two, I'm going to get plus 1. So putting it in terms of cosine and getting rid of the complex fraction, I'm down to this. Look where I'm trying to get to. So again, I can look at that and say, well, I want a 1 minus cosine in the numerator. So let's multiply by 1 minus cosine over itself. And I'm only know to do this because I kind of peeked and looked to see where we wanted to get to. So what do I get? I get 1 minus cosine over this one. I FOIL things out because it's really 1 minus the cosine times 1 plus the cosine. They're conjugate, so I'm going to get 1 minus cosine squared. Now, if you weren't sure you could do that, actually take and FOIL this out. You know, cosine times 1, cosine times negative cosine. 1 times 1, 1 times negative cosine. And you should see you get this. Then I look for this Pythagorean identity because I want to keep this on top. I want this to be sine squared, and when I think about the Pythagorean identity, it is sine squared. So now I can do the trig identity and say that that's the same thing as sine squared. Okay, so that's numbers 1 through 4. I'll do a second video to give you 5 and 6. Hope that helped.